Hello Finxters and welcome to a new Pandas tutorial. Today we will learn about the Pandas apply function, which is used to apply any kind of other function to our data frame or series, and it's used to segregate our data or change it with just a very limited amount of code. To get started, we will have a look at an introductory example. First we import the Pandas library, then we create a Pandas data frame and assign it to the variable df. And the data frame contains values between 1 and 9 and has some basic column and index labels. And yeah, if we output the data frame, you see that it's a typical Pandas data frame with just very basic content. And now we use the apply function. We say df.apply, and inside the apply function it expects a function that we want to execute on our data frame, and we will just use the sum function, and the output shows the sums of every column, as you can see here. So for example, column 1 has a sum of 12 if you sum up all the values in column 1. And the sum function is a built-in Python function, and yeah, as we can see, it sums up the columns here. And additionally, we get the data type as the output in addition to the actual values, and it's int64. That's because our values here are integer values. So by default, the apply function executes like the function on the columns, but we can also do it to be executed on the rows, and therefore we have to specify the access parameter. By default, it is set to 0, and if I do this, access equals 0, we get the same output, but we can also apply 1, and if we do that, we see that now we get the sums of the rows instead of the columns. So we can specify by which axis we want the function to be executed on. By now we have seen the sum function, which is the built-in Python function, but there are lots of other built-in Python functions. For example, the max and min function, which I will show you now. We just say df.apply max, and this calculates the max values of every column. Again, it calculates by column because we didn't specify the access parameter. We could also apply the min function, which, as the name suggests, applies the minimum value of every column. Or we could, of course, apply the access parameter, assign it to 1, so we get the row values. There are lots of other built-in Python functions that we can use. We have just seen a few now. We can also use built-in Pandas functions. For example, the not null function, and this is how it looks like. We have to state PD before we apply the Pandas function to say the program that we want to use a Pandas function and not a built-in Python function. And the not null function basically detects if the values are existing or not. So in other words, it checks if a value is not a null value or an NA value. And if the values exist, they just print true. And since we had only integer values there and they all existed, the data frame now contains true values because every value existed. And we can, of course, also apply functions from other libraries, for example, the NumPy library. But to do that, we, of course, have to import the library that we want to use. So we import NumPy as np. Then we are able to apply a NumPy function. For example, we could apply the sqrt function. Again, we have to state np before we use it to state, okay, we want indeed to use a numpy function here, sqrt. And this numpy function calculates the square root of every value. And as you can see here, the output shows indeed the resulting data frame with the square root of all the initial values. Yeah, built-in functions are very great to apply, and for most use cases, or for a lot of use cases, you find a built-in function from any library that you can use. But sometimes we need to do very specific calculations, and then it's often the case that there is no built-in function that we can apply. But for that we can, of course, create our own functions. Let's say we want to categorize the initial data frame, say which value is small or normal or big. We could define a function. Let's call it categorize. And if the value is smaller or equal to 3, let's show should return small. And if the value is bigger than 3 and smaller than 6, then we return normal. And in any other case, so if it's bigger than 6, then it should return big. And this is the function that we use now. It's the custom function that we created, and we can apply this now inside the apply function. So let's say we want to categorize, let's say the first column, then we can do this, df, the name of the column, which is col1, dot apply, and inside the parentheses we state the name of the custom function. In this case it's categorize. And if we output that, then you can see that the output shows the category for each value in column 1. So the value in column 1 and row 1 is small, and row 2 is normal, and row 3 is big. Yeah, and that's a very nice way to apply customized functions. But sometimes these functions are very short and they have only one expression. In this case, it's more efficient and more convenient to apply a function to our data frame that is called a Lambda function. And basically a Lambda function is a small function that fits into one line and has no particular function name. So let's say we want to, I'll just show you how it looks like without a Lambda function and then compare to that with a Lambda function. Let's say we want to add 2 to every value in our data frame. Then we could create an own function. Let's call it +2. And it says return x + 2. And then we can apply this function to our data frame. And as you can see, now we have added 2 to every value. And compared to that, we can use a Lambda function where we don't need to specify this +2 function itself. And this approach looks like this, df.apply. And then we have the keyword lambda. And then the argument is x, and the expression is x + 2. And as we can see, this creates the same outputs, but it's just a very, just much shorter way and more convenient way. And yeah, but some drawback is that we can only have one expression. So, for example, the categorize function that we used earlier would not be possible to be created with the Lambda function because it has multiple expressions. So in that case, it's better to use a completely customized function, but for very short functions with just one expression, it's a cleaner way to use the Lambda function. And yeah, that was the tutorial. The apply function is a very essential tool, to put it in a nutshell, and it allows us to perform any kind of function on our data frames, built-in functions from the Python, Pandas or NumPy, or any other Python library, or we can use customized functions, whole functions or Lambda functions, whatever. And yeah, that was the tutorial. Thank you for listening, and I see you in the next video.